All right, welcome back, guys. So today we're going to do another lesson on solving equations with fractions. I know fractions are not anybody's favorite. So I'm hoping that yesterday and with some more practice today, you guys will feel more comfortable dealing with them, especially with the method I'm teaching you where we actually get rid of the fractions to make our lives a little bit easier. So I sort of started you off yesterday. I'm going to give you some more complicated examples, some examples where we have more than one fraction in it. Start with 2, and the next example I'll throw a couple extra ones in there. So if you take a look at this example, we have 1/4 x plus 2/3 is equal to 6. Now, many of you guys are going to look at this and say, I don't know what to do with 1/4. I don't want to deal with 2/3. You probably don't mind the 6 so much. So what we want to do is we want to look at our two fractions, or however many we have. In this case, we have 1/4 and 2/3. And we're going to look at the denominators of them, those bottom numbers. We don't necessarily care about the numerators right now. So one denominator is a 4, and the other one is a 3. So we need to think of a number that both 4 and 3 can go into. So we're trying to figure out a number that 4 and 3 will go into that we can multiply by so that we can get rid of the 4 and the 3. Now, if you don't know a number, a little trick is you can always multiply the 4 and 3 together. So in this case, 4 times 3 is 12. So one thing I could do is I could multiply here every term by 12. And so watch what happens when I do this. 12 times 1/4, you can use your calculator if you feel like you need to, but 4 goes into 12 3 times, so it's going to be 3 times 1, 3x. Do 12 times 2/3, 3 goes into 12 4 times, so this will be 3x plus 8. And then over here, 6 times 12, 72. So I have 3x plus 8 is equal to 72. Now this problem looks a lot easier for me to solve. It's now just a two-step equation. I'm going to subtract 8 on both sides. So I'm going to get 3x is equal to 72 minus 8, which is going to be 64. And then I'm going to divide both sides by 3. Now sometimes, and this is a good example of it, our answer is not going to come out perfect. It's not going to be a whole number. It's going to be a fraction. In this case, our number is 64/3. You could divide in your calculator and do 64 divided by 3. That's fine. You'd get 21 1/3 in this case, or 21.3. I would take either of those answers. Most of the time, you're going to see the top one here, 64/3. All right, let's do one more quick example here together before I get you out of here. All right, this time I'll throw a few more fractions in here just to show you what would happen. If we have something like 1/2 x minus 1/4 equals 2/3 x plus 1/6. All right, so this time I've got a ton of fractions. So I want to look at all of them. 1/2, 1/4, 2/3, 1/6. I look at my denominator. I've got a 2, a 4, a 3, and a 6. I need to find a number that 2, 4, 3, and 6 can all go into. You might do a little bit of trial and error. Hopefully, if you think for a second, you come up with a number. In this case, I would probably use the number 12. 2 can go to 12, 4 can go to 12, 3 can go to 12, and so can 6. So I'm going to multiply each of these terms by 12. This will allow me to get rid of all my fractions and make this a much more manageable problem for us. 12 times 1/2 x, 6x. 12 times 1/4, negative 1/4 I should say, is going to be a -3. Equals 12 times 2/3 x is going to be 8x. And over here, 12 times 1/6 is going to be a +2. All right, now this looks like a much better problem for us, a problem that we did last week quite a bit. Variables on both sides. So I'm going to subtract 6x on both sides. I'll be left with -3 equals 2x plus 2. I'm going to subtract 2 on both sides. I get -5 equals 2x. And I'm going to divide both sides by 2. And so I'm going to come up with two different answers here. -5/2. So x equals -5/2. I would just leave it like that. Or if you feel compelled, you can put that in your calculator and get -2.5. Either of these answers will work and both are correct. All right, hopefully this is making multiplying by those fractions a little bit easier and solving those equations that look really messy to start with. Hopefully you found this helpful, but let me know if you have any questions.